Hello and welcome back everyone. So in this video we're going to talk about the physical layer and the data flow within the physical layer and what is a physical layer. So first of all, the physical layer is the physical connection between two locations. This physical connection can be either guided or unguided, so it can be like from A to B through a wire, or can be wireless like the Wi-Fi, or can be through Bluetooth, or so on. So we must understand how this transmission happens and how the data is being transferred, and what are the types of connections in the physical layer. So first of all, there's something we're going to talk about called the data flow. So data flow happens through one of three methods. So there's something called the simplex. The first one is called simplex, and there is the half duplex, and there is the full duplex itself, full duplex. So each one of these happens through a certain method. So the first one is the simplex. So let's say we have device 1, and here's the first device, and this is the second device, and there's the first device, and here's the second device, and here's the first and the second. So for each of these to transmit, the first one is going to send the data to the second one, and that's it. So the traveling way is unidirectional. So to two devices, one only works as a transmitter and the other works as a receiver, an RX. So this is the simplex. This happens to be the simplex. It's just that simple. One is a receiver and the other is a transceiver or a sender. So the other method is the half duplex. Half duplex happens that the TX sends, there is a line between both of these. The TX sends to the RX, okay? The TX sends to the RX. After this operation happens, or this communication is done, RX sends back to the TX. So here the TX becomes the RX and the RX becomes the TX. So after TX has sent, the RX sends back to become TX. This differs from the full duplex, that there is a single line. Also, this is a single line, but after this TX finished sending to the RX, the other operation happened. Here in the full duplex, both of them operate as a sender and receiver whenever they wish, without intersecting. Like the TX is an RX, TX is RX, and RX is TX normally. Nothing can stop them. So both sending and receiving happens in the same time. So here is a time variable. So time is a variable. So here happens both on the same time. But here the first operation finishes, whether it was sending or receiving, then a second operation happens. So simplex, it's a unidirectional half duplex, sending and receiving, but step after step. This finishes sending, then it sees whether it's send or it receive, and the full duplex send and receive in the same time. So this was the data flow. The first thing that was the data flow. Second thing we're going to talk about here is the physical structure itself. So the physical structure can have different types of connection. This is different from the topology. Type of the connection can be into a type of connection itself can be type of connection can be whether it can be point to point or P2P, point to point, and there is sometimes called peer-to-peer, and there is multi-point. In a point-to-point, it happens that the first device is connected to the second device. Sounds simple, yeah? This is a point, this is the first device, and this is the second device, and both are connected to each other. But here, in the multi-point, this device is connected to multiple devices, but on the same line. I'm not talking here on different lines. I'm talking on the same line. It's connected to multiple devices. so it's connected device B and C and D, all on the same line, all on the same connection. So in the point there is a dedicated link between the two devices. Here the link in the multi-point is shared between two or more devices. Here the entire channel capacity or bandwidth is reserved to these two connected devices. But here there is a single transmitter and multiple receivers. Yeah, there is multiple receivers here. Here is this is an example for like the remote control, only one controller for one TV or one receiver. Yeah, but here is an example for what we actually use here in the internet computer communication, which is the Ethernet and the ATM machines, but we're not gonna talk about that. But here in the Ethernet, the one single cable is connected to multiple cables through something called a hub. We are going to talk about it is that it is like the switch. Yeah, it seems like the switch, but the switch is in the data link layer because it saves the MAC addresses. We're not gonna talk about the MAC addresses now, but it is different than the hub. That the hub is like an extension cord to all of these cables. Like all of these cables are connected to each other. They are like extended to each other, of making them all connected to each other normally. It's broadcasting. All of these are a single cable. But if it was a switch, this switch is more smarter. It does save MAC addresses, tables, and so on, and sometimes goes to the third layer. So this was the first part. The second part is the physical topology. Topology is one of the most fun parts about IT usually, in studying IT, of course, not in the actual real life. The topology can become one of four things. It can be more, of course, but we're going to talk about the static and dynamic. So we're going to talk about a mix of them. The first one being the bus. Yeah, the first one being the bus, and there is the star, and there is the ring, and there is, of course, the most famous of them, the mesh. Okay, so starting with the bus. The bus is all of these are like nice to know things. Bus is like a long line, a long cord. This is the bus topology. A long cord being connected, this is called backbone. So this is the this is the bus. We're going to talk about the bus now. So this is the backbone, and this backbone is multiple devices are connected to this backbone. The advantage of this is it's simple, just a long line connecting multiple devices. Yeah, it's cheap, doesn't require too much engineering around it. It's just simple multiple devices being connected to a single backbone. Yeah, but the disadvantage that all of these devices connect to this backbone. So let's say this device wants to send now, this other device wants also to send. There happens to have collision. So if we want to talk about advantage and disadvantage, so advantages of this is cost is a good cost. It has low cost. It is simple to make. Yeah, it's usually the good thing about this. The disadvantage of it is the bus is the collisions and speed. Speed. Let's say let's call it speed. And yeah, there's multiple other problems like the cost of implementation. The cost of implementation is actually good, but difficulty to identify the problem. Problem. What is the problem here? Like if there is a problem that occurred here, like let's say it's here, and you are connected on your device here. The backbone, there is a problem in the backbone now. Is it on the left, on the right? You don't know. Yeah, it's a single connection connecting all of these devices on one single line. If this line fails, everything fails. stack your backbone. Then there is the star or the ring. The ring topology is not really used like in the current situations, but there's two types of rings. There is the unidirectional and the bidirectional. So the unidirectional, this device is connected to this device, sending here, sending there. So if a cable here fails, the whole connection fails. So this is the unidirectional. But if it happens to be bidirectional, let's say we have our 4 devices again connected on a shape of a ring like that. They can be bidirectional. So if, let's say, this cable fails and you are trying to send from this device to this device, so instead of going like that, instead of going this direction, if this direction fails, it can go the other direction. So this is bidirectional. So this is good back then, like back then in the back in the days, this was something good, and it's usually used in the lands of the laboratories, and it simulates the satellites around the world, the satellites in the LEO space, the satellites that connect to our internet. Like to say, this is the world, and these are a bunch of satellites. They're usually connected in a shape of a star, in a shape of a ring, I'm sorry. Then, so this is not really that much to say about the problem. We can say that there is advantages and disadvantages. So the advantages and disadvantages. So the advantages, it flows, if it flows in one direction, if it flows in one directional, it reduces the chance of collision. Collision is lower, and it provides in bidirectional, it provides as an alternative path. Alternative path. So as you can see here, if there is an alternative path, if one of these nodes fail, or one of these cables fail. The problem here is in the unidirectional, there is a single point of failure, which makes it something bad. Like if one of these nodes fail, the entire connection fail. Something else here is the entire connection. Is dependent. It's dependent on the processors, on the other devices. Like it's like if you want to send, like say you want to send this packet from here to here, so it depends on that these both two are in a ready state for sending this message. It's not always the case. They may be sending to each other, or delayed, or even not open. So this is it's the problem. It's dependent on other devices. The other connection, the third connection here, is the star. The star is the actual one we use in our daily lives, in our connection. Let's say we have a router here, or a hub, and this hub is connected to multiple devices. This is actually the best one. Yes, it's costly. We can actually say the advantage and disadvantages right now. It's costly because it requires a hub here. The hub here is or a router is actually expensive. It's not simple. Sometimes it needs also setup. It needs setup. The setup, the price is high. But the advantage here is if a node fails, failure is lower here. Why? Because if a node fails, the other devices are working. Something else, it's super fast. It's speedy. If this is a single node connecting everything to each other, it knows what's connected. It manages all of these connections, and it's all direct, peer-to-peer. No devices is connected to other devices. So, and it's dedicated for this action. The fourth type of this of this setup is the mesh. So the mesh is the fourth type, and the mesh is as following. The mesh is all devices are connected to each other like that. Like, so let's say this, we have 4 devices. This device is connected to this and this and this, and this one is connected to this and this, and of course connected to this. This is connected to this and this and everything. So all connected is connected to each other. It follows an equation of the summation equation. So what is the summation equation? It says that the number of lines is equal to like the number of devices times the number of devices minus 1 over 2. So let's say we have here, for example, here we want to know how many connections exist. So the number of connections, here we have 4 devices, so 4 times 4 minus 1, which is 3 over 2. So 12 over 2 is 6. We're going to count them. We have 1, 2, 3, 4, 5, 6. We have 6 connections or 6 links, which means this is a disadvantage and an advantage in the same time. This disadvantage here is cost. You need too much cabling. But the advantage here is that there is always an alternative path. The uptime, or the let's say the alternative path is always existing. It's everywhere. Like if this failed, we're gonna go up and there. If this fails, it's gonna go there. Yeah, so there's always a better path, and even if the network gets bigger, it gets even better. The actual, after we have talked about these topologies, the actual thing that happens in our current life is something called the hybrid topologies. So the hybrid topologies is a connection between multiple of these topologies. Like one of them is the tree topology, or it's sometimes there is the tree, which is a device or a central device. It's called also the hybrid. A switch, as we have talked about, it's like a star which is connecting multiple devices, and these devices connect to each other by bus. Yeah, so it makes the current structure of our devices here. So let's say this is the central router of the house, and these are multiple devices connected to multiple devices. So yeah, the third thing we're going to talk about, this was the topology. The third thing we're going to talk about is the network size. So based on size, there are different structures for the network. It can be through LAN, or it can be MAN, or it can be WAN. Yeah, these are very very popular. So LAN is like the Wi-Fi in our house. Wi-Fi is why is it a LAN? Like people sometimes think it's a WAN. No, it's not a WAN. It's a LAN. Why is it a LAN? Because it is in a low range. It's usually up to 100 meters. Yeah, our Wi-Fi, the 2.4 gigahertz Wi-Fi, for instance, is on a low distance, which is 100 meters. About the MAN, it's usually like multiple kilometers. It can reach multiple kilometers, up to sometimes we say like 5 to 50 kilometers. And in the WAN, it's beyond all of these numbers, 50 to 150 plus, or let's say 100 plus even, is kilometers. Okay, so that was about the distances. What about the devices itself? What about the connectors? What about the connectors and stuff? So LAN, there is something, the Ethernet, the cable in our house. We're gonna talk about this in the other part in the physical layer. The Ethernet, the Wi-Fi. There is also the coaxial cables. This Ethernet cable is, or the Ethernet is also a protocol. Like it goes to a protocol standard of IEEE of 802.3, if I remember. um, this is a protocol managing the Ethernet, but the cable itself is called CAT. The current one we are working usually on is Cat 5A. It's the type of cable itself. Yeah. Here in the MAN there is something called the WiMAX, for instance. WiMAX. There is the optical fibers, fibers. Yeah, they usually create the backbone of devices of the internet. And in the WAN there's like the satellite connections, satellites, and there is also things like the radio stations. They can go through cities, they can go beyond cities, they can go countries sizes. Yeah, radio stations. So that's also one of the things that differs a LAN from a MAN from a WAN. Also, what they stand for: the LAN is the local area network, MAN is metropolitan area network. It's like a city size, so this is like house size. It's maximum of a house. This is metropolitan, it's like a city size. And this is usually like country size. Yeah, country or multiple governments. Yeah, size. Yeah, so this is the difference usually in sizes between MAN and LAN and WAN. So the next part is going to be talking about is going to become the fourth part, which in the physical layer, which is the transmission medium. Yeah, we are going to talk about this in a different video, in the next video, about the transmission medium. And I think this is enough for this video, and thank you very much for watching. I will be continuing in the next part, and thank you very much. Bye bye.